go to page 309, and let's start with number 467. Okay, so it says how many odd positive integers are factors of 480? So with 480, to find the factors, you need to break down into prime factorization. So break down to 2, to 240, 2, 120, 2, 60, 2, 30, 2, 15, and try 3, 5, and I'm going to divide by 5 again to get 1. Okay. So all the factors are made out of a combination of these factors. Okay. Now, in order to be odd, you cannot use any of the 2's because as soon as you involve the 2, it becomes an even. So you only can use combination of 1, 3, 5. So this will give you number 1. This will give you 3. This will give you 5, 5, and this will give you 15. Okay, so these are 4 odd factors you have. So answer will be 4. There are 4 factors that are odd. So 1, 3, 5, and 15. Right. Okay, let's go to 468. Okay, it says less than 50 people, so n is less than 50 at a party, and each person shake everyone else's hand. If there is an odd number of total handshakes at a party, what is the largest number of people? Okay. So this would be a combination problem. So there are n number of people, and you take 2 people to perform a handshake. Okay, so number of handshake would be NC2. Okay, and so this would be equal to n. Well, this is 2, so it would be 2 factorial, so it would be 2 and 1. And therefore, there would be 2 numbers up here. And so it would be n minus 1. Okay, and this is odd. So since n had to be less than 50, so biggest number n would be 49. So let's try 49. So when n equal to 49, you're going to get 49 and 48 over 2 and 1. Now if you notice that when you cancel things out, this one is still even, so this one is no good. Okay? So what we can learn from this is that the number can be even but cannot be multiple of 4, because when you have multiple of 4 and you cancel with 2, it's still going to be even. Okay, so that's going to go down to the next number. So if n equal, so this is n equal to 49, so n equal to 48. So you're going to get 48. Right away, it's going to be no good, right? Because you got a 48 over here. Okay, again, when you cancel, you get 24 and still even. So this one is no good. So when n equal to 47, you get 47, 46, 2, 1. So even this is an even, but when you cancel with a 2, it becomes an odd. So this one is good. Therefore, the answer is n equal to 47. So there are 47 people at the party. Okay, let's go to the next one. Okay, number 469. So how many lines are determined by 12 points on a plane? No 3 of them are collinear. So you got points, right? So it takes 2 points to make a line. So again, there are 12 points, and you take 2 points to make a line, and none of the points are collinear. Okay. So if there are collinear points, then you have to take away those collinear lines, the points that form the collinear line. So again, there are 12 points, and take any 2 points to form a line. So 12C2. So this is equal to 2, 1, and on the top would be 12, 11. So cancel out. So answer is 66. So there are total 66 possible lines. Okay, for 470. Okay, number 470, there are 4 red chips. Okay, so I'm going to use this to indicate red chips. And there are 2 white chips. And they are in a circle. Okay, so how many can you perform these? So in a circle, so I'm going to put this in here first, okay? And then, so the point becomes to place the 4 red ones. So you can have all 4 on this side and none on this side, okay? Now 4, 0 is same as 0, 4. So if you put 0 here, 4 over here, it's same as when you rotate, right? So 4, 0 is identical to 0, 4 because it's a circle, so you can rotate. And the next one would be 3, 1. So you got 3 red one here, 1 red one here. And you got 2, 2. And and that's it. Because again, if you go 1 3, it's same as 3 1 because it's circle, it can rotate. So the answer would be 3. There are only 3 ways to do this. Okay. So again, you can put 4 red 1, no red 1, right? 4 0, or you can put 3 1, you can put 2 2. Okay. Okay, let's go to next one. Okay, 471. How many ways can 5 books be arranged on a shelf if 2 of the books must remain together? So for this kind of problem, when the items have to stick together, you have to treat as one. So basically, instead of 5 books, you have 3 singles and 1 double. So you actually have 4. Okay, so you got 3 single and 1 double. Okay, and so you got 4 items you can rearrange. So it'd be 4 factorial. But the double, the 2 books have to be stick together. You can have either AB or BA. So you have to times it by 2. Okay, because you can have there are 2 ways. You can have the AB in that double, or you can BA. And so this is equal to 4, 3, 2, 1, and 2. And so this will equal to 48. So there are 48 different ways. Okay, let's go to the next one. Okay, number 472. What is the sum of all the integers less than 100? Okay, so less than 100. Which have exactly 12 divisors. Okay, so you have 12 divisors. So divisors are your factors. So what number less than 100 have exactly 12 factors? Okay, so what we need to do first is break it down to 12 into factors. So 12 equal to 1 times 12. Okay, so remember the exponent would be 1 less than the choices. So the exponents to get those choices would be equal to 0 and 11. And so 11 is a very high exponent. So if you try the lowest number, it would be 2 to the 11. So 2 to the 11 equal to 2048. So this is no good already. So this is not going to work. So let's try 2 times 6. So that means the exponents. So number of factors of 2 and 6 would be, exponent would be either is equal to 1 and 5. Okay. So if you try 2 to the 1 times 3 to the 5, and this will give equal to 243. So this is no good. So you try 2 to the 5 times 3 to the 1, and this is equal to 96. So this one is good. Okay. Now you also can try, instead of 2 and 3, you can try 2 and 5. But if with 2 and 3, you already kind of reach into your limit already. So if you try 2 to the 5 times 5 to the 1, it's going to be exceed that already. Okay. So and also so again, this is already kind of to the limit already. So if this is 5 to the 1 or 7 to the 1, it's going to be no good already. Okay, so let's go and try the next combination. So try the 3 and 4. So the exponents that you need to achieve those choices would be 2 and 3. Okay. So again, the choices would be always one more than exponent, because you can choose none of them, or you can choose one of them, you can choose 2 of them. That's why it's 3 choices. Okay. Okay, so 2, 3. So you can try 2 to the 2 times 3 to the 3. This is 108. So this is no good. Now you switch the exponent. So you got 2 to the 3 times 3 to the 2, and this will give you 72. So this one is good. Okay. So you continue on. So 3, 4. Now you run out of the two factors, right? Now you can also try 2 times 2 times 3. Okay. So the exponents that you need to achieve those choices would be 1, 1, and 2. Okay. So let's go and try 2 to the 1, 3 to the 1, and 5 to the 2. Okay, and this will give us 150. So it's no good. So again, I'm just going to rotate the exponent. So it'll be 2 to the 1, 3 to the 2, 5 to the 1. Okay, So again, exponent 112, right? 112. And this will give me 90, so this one is good. So circle that. And again, I'm going to continue on. So it'll be 2 to the 2 times 3 to the 1 times 5 to the 1. And this is equal to 60. So this one is also good. Okay, but remember, this is not 2, 3, 5 are not the only one you can try. Okay, you can try 7. So you can 2 square, 3, 1. Again, because all you have to do is have the exponent of 112, right? Okay, so times by 7 to the 1. And this will give you 84. So this one is still good. But when you try to like, you only can try prime numbers. Okay, so if you try 11, it's too much already. And if you try like 2, 5, 7, it's going to be too much already. Okay, and so that's all the possible combinations. So you're going to add all this together. So you got 96 plus 72 plus 90 plus 60 plus 84, and it's equal to 402. Okay, let's go to page 309 and number 473. Okay, it says at the end of the professional bowling tournament, the top 5 bowlers have a playoff. So in the playoff, only 2 people play at a time. So first playoff is number 5 bowls number 4. The loser receives 5th prize, and the winner bowls number 3 and 4. Not again. So for this, by reading through this, you realize there are total 4 games. Okay, there are 4 games, and each game has 2 outcomes. So each game has 2 outcomes. So first game has 2 outcomes, second game 2 outcomes, and so forth and so forth. So this is going to equal to 16. So there are total 16 different ways to receive the prize. Okay, 474. You have set A equal to 1, 2, 3. And set B equal to A, B, C, D. Okay. So how many different functions are there that assign one element of B to each one of these? So you assign one of these to each one of these. So now you can have 1A, 1B, 1C, 1D, 2A, 2B, 2C, 2D, 3A, 3B, 3C, 3D, okay, and so forth and so forth. Okay. Okay. So anyway, number 1 has 4 choices because you can have A, B, C, D. Okay, and the 2 can also have 4 choices. 3 can also have 4 choices, and therefore there are a total of 64 possible ways. Okay, let's go to 475. Okay, so palindromes. Okay, for example, like 2, 3, 4, 3, 2. Read the same forward and backward. Find the sum of all the 4-digit positive integer palindromes. Okay, so we did the 3-digit one earlier, so it's not too bad. But the 4-digit ones are much more complicated. Okay. Okay, and so forth, right? So let's start with the ones. So if this is 1, this is 1, okay? And this can be from 0 to 1, 2, 3, 4, all the way down to 9, right? Same thing, this digit came from 0, 1, 2, 3, 4, all the way down to 9, okay? And the second one would be 2, and again, palindrome has to be the same, okay? And this can be, again, from 0 all the way down to 9, 0 all the way down to 9, right? 1, 2, 3, all the way down to 9. And the same thing for 3, right? So again, 3 all the way down, so 3. And this can be the 1, 2 all the way down to 9, 1, 2 all the way down to 9, right? And so forth and so forth. Okay. So notice that, so you're going to, for this one, you can have 1, 0, 1, 1, 1, 2, and all. So there are 10 of them. Okay? So there are 10 of these. So that's going to take care of the first digit first. So first digit, so notice that 10 1s, 10 2s, 10 3s, 10, 4, and 10, 5. So basically, you're going to add 1 plus 2 plus 3 all the way down to 9, and there are 10 of sets of these. Okay, so 1 plus 2 plus 3 plus all the way down to plus 9 is equal to 45. Okay, so I'm adding horizontally for first stages, so 1 plus 2 plus 3 plus, so there would be a 45. Okay, and each of that, when you add horizontally, there's 45, and there are 10 of them, right? So you have to times it by 10. Okay, and this is in 1,000 digits, so you have to times by 1,000. Okay. Now plus the second digit. Okay, the second digit you have to do it vertically. So you add from 0 to 9. Okay, so that's 45. Okay. And this is 100th place, so you times it by 100. Okay, and there are 9 of them, right? Because there are 9 sets, right? 1, 2, 3, and you can follow that, right? So this is 1, 2, 3, right? So all the way down to 9. Now remember, first digit cannot equal to 0, right? So there are 9 sets, so you have to times it by 9. Okay. Now this digit is the same as this one, right? So again, you add vertically, so that's 45. Okay. And this is in the 10th place, so you have to times by 10, and there are 9 sets. There are 9 sets, so times by 9. Okay. Now this digit, the fourth digit is same as this one here. Okay. You have to add horizontally first. So notice the middle number you add vertically first. The outside number you have to add horizontally. So you got 1, 2, 3. So you have to 1 plus all the way up to 9. So that's 45. Okay. And there are 10 of them. Well, actually, okay, each one of these is worth 1. It's unit digit, so times by 1. Okay. Well, let's multiply by 10 sets first. Okay, so 1 plus 2 plus 3 all the way to 9, that's 45. And there are 10 sets, right? Because all these are 1s, right? So there are 10 sets, so times by 10. And this is a unit digit place, so each one is worth 1. Whereas this over here is thousands place, so worth 1,000. Okay, so this is equal to 45 with 4 zeros. And this will be 405 with 2 0. And this would be 405 with 1 0. And this would be 450. Okay, you add all this together, give you 495 000. Okay. Okay, let's go to the next one. Okay, for the greatest number of n for which 12 to the n evenly divides 20 factorial. Again, when I say divides, means it's a factor. Okay. So you got 12 to the n. Well, first let's go and break this down into prime factorization. Okay, so 12, so 2, 6, 2, 3, 3, 1. So 12 equal to 2 times 2 to the square times 3 to the 1. Okay, so 12 is equal to that. And multiply also, you're going to get 2 to the 2n, 3 to the n. And this is going to be a factor of 20 factorial. Okay. So we need to figure out how many 2's are in here. Okay. So 20 factorial is 20 times 19 times 18 times 17 and so forth. So therefore you have to figure out how many 2's are in this number. How many factors of 2 are in here? Well, whenever you get into so 20 factorial equal to 20, 19, 18, 17, 16, 15, 14, right? So you're going to get a factor of 2 here, 2 here, 2 here, 2 here, right? Okay, so multiple of 2, there are 10 of them. So you're going to get a factor of 2 for all the even numbers. So there are 10 of them. Okay, and multiple of 4. Okay, like for example 4, there are 2 of them. It's 2 times 2, right? So you're going to have an additional factor of 2. Okay, so there are 5 additional ones. Okay, so 4, 8, 12, 16, and 20 have additional 5 more 2's. And then you have the 8. Okay, so this divided by that will give you 2 additional. So at 8 and 16 have additional 2 factor of 2, right? Okay, and then the 16, again, you're going to get 1 additional factor of 2. So again, this one you get 2, 2, 2, 2, right? Okay. So therefore, with all these, there are 18 2's. Okay? There are 18 2's. And so 2n equal to 18, so n equal to 9. Okay? Now we have to account for 3's. Okay? So for 3's, again, multiple of 3, you're going to get 6 of them, right? So you get the factor of 3 at 3, 6, 9, 12, 15, and 18. Then you have to have, so 9 will give you additional factor of 3, right? So you're going to get another 3 at 9. So 20 divided by 9, you're going to get 2. And then you're going to get 27, right? Exponent of 3. So this one cannot. So if the number is bigger, then you're going to get more over here. So this one equal to 8. Okay? And so from here, you're going to get n equal to 8. Okay? And therefore, the answer would be n equal to 8. Because you only have 8 3's in here. So that's not enough to make the 9. Okay? Not enough to make the 9 sets. So that's only 8 3's. So therefore, you only can make 8 sets over here. So n equal to 8.